6.3, this is number 4 in the homework. And the directions here say, in a survey of 2,144 adults in a recent year, 12,096 say they have made a New Year's resolution. It says construct a 90% and a 95% confidence intervals for the population proportion, interpret the results, and compare the widths of the confidence intervals. Okay, so before we do our confidence intervals, let's find our p-hat. The way we're going to find our p-hat is we're going to take the number of people who said yes, this is our 1296, divided by this is going to be my n in this case, because we surveyed 2,144 people. Okay, and so let me take my calculator, it's right here, let me clear all this stuff out. 1296 divided by 2144, oops, delete, 44. Okay, let's convert this now to a decimal. And so I'm coming up with 0.6044. I'm going to go ahead and go to 3 decimal places, and I'm going to explain why I'm going to go to 3 decimal places. I'm going to go to 3 decimal places because my answer is asking me to go to 3. So I'm going to go ahead and leave that as 3 right now. The next thing we need to find is we need to find our q-hat. Okay, so q-hat is just going to be 1 minus p-hat, and that's going to be 0.396. Okay. Now, the next thing is we're looking for a 90% confidence interval. Okay, so let's get a visual of what that's going to look like. So I'm going to draw my normal curve here. 90% means that the area underneath the curve in the middle is going to be 90%. So I'm going to have 10% left for each of those, and half of 10% would be 5%. So as a decimal, the area underneath this curve is going to be 0.05. That's how we write 5% as a decimal. So remember, I need to find my 2 critical values. One's going to be negative, one's going to be positive. And the way I'm going to do that is I'm going to use my inverse norm feature, because I know the area here is 0.05. So let me get my calculator. Let me go second vars, go to inverse norm 0.05, and I'm coming up with negative 1.64. You know what? If we're going to use 3 decimal places, go ahead and use them here too. Negative 1.645. Okay. So this is a negative 1.645, and this is a positive 1.645. Okay. Next thing we're going to do is we're going to find how do we compute our error. So guys, I just copied this directly from our notes. And here's the formula for finding my error. It's going to be my ZC times the square root of P hat Q hat over N. So this is going to be ZC times square root of P hat Q hat all over N. Okay. So now the ZC, I'm using 1.645, okay, times big square root of 0.604 times 0.396 all over my N, which was 2144. Okay, so I'm going to do this part right here on my calculator. Clear this out. 1.645 times the square root of 0.604 times 0.396 divided by 2144. And now I'm going to hit enter. And to 3 decimal places, I'm coming up with 0.017. So 0.017. Now, the way I'm going to find my interval, it's going to be P hat minus E and P hat, P hat plus E. Okay. So let's just do this part on the calculator. Remember, my P hat is at 0.604. So let's clear this out. 0.604 minus 0.017. 0.587, and I'll do it again, but with a plus in the middle. 0.587, 0.621. 0.587, 0.621. Okay, so here is my confidence interval for the 90%. So now I'm going to do the same thing we did a little while ago, guys, but I'm going to do it now for the 95%. Okay, So I'm going to do this for the 95%. Remember, my p hat is still 0.604. My q hat is still 0.396. And my n is still 2144. If I'm doing this now for the 95% confidence interval, that means the area underneath the curve here is 95%. So we have 5% left for those two pieces, which means that each piece is going to have 0.025, okay, or 2.5% will be the area underneath that curve. So now we're going to find our new critical values, right? Okay, so let's go ahead and do that. Let me take my calculator, second vars, inverse norm of 0.025. And I'm going to go ahead and go to 3 decimal places here. So I guess I would write negative 1.96. Let's see. This is a negative 1.96 and a positive 1.96. Okay, so let's go ahead and find our error. Remember, it's going to be ZC times square root of P hat Q hat all over N. So it's going to be 1.96. P hat is 0.604 times 0.396 all over 2144. Okay, so let's do this part on the calculator. 1.96 times the second square root of 0.604 times 0.396 divided by 2144. And let's see, now we can hit enter. I'm going to go to 3 decimal places, 0.021. 0.021, okay. And so now, remember, the way I'm going to find my confidence interval is I'm going to take P hat minus the error, P hat plus the error. So in our case, we're going to have P hat was 0.604, 0.021. Okay, so clear 0.604 minus 0.021, 0.583, and then let's do it again, but with a plus now, 0.625. So we have 0.583 and 0.625. Okay, so now, found the confidence intervals for both of them, okay? So let me write it. I'm going to write it on a new page, 0.583, 0.625. 0.583, 0.625. This is my 95% confidence interval. And the one that we came up with for the 90%, 0.587, 0.621, 0.587, 0.621. This is my 90%, okay? The question usually asks us, which one of these is wider, okay? So let me go ahead and do this one here first, 0.583. I'm just going to put a mark here, 583, and 0.625. Okay, so now when I have to think about 0.587, that's going to be further to the right, okay? And when I have to think of 0.621, that's going to be further to the left. So here's my 90% confidence interval, okay? And here is my 95% confidence interval. Which one is wider? The 95% is the wider one, okay? So anyway, I hope that helps, guys. If y'all got any questions, please let me know.